Hello and welcome to the 13th IGCSE math tutorial, and today we're going to get started on mensuration. It's basically things like area, perimeter, and this is where the fun begins, because I don't know, I didn't really get into the algebra that much, but this is all I find a lot more fun. So first we need to know the area for some shapes. Everyone should know these ones before continuing on. For a rectangle, I'm actually going to do this in a sticker or a pen. For a rectangle, this is L, this is B, also known as H. Area, which we'll refer to as A throughout this tutorial, equals BL, or BH, or base times the height. So, that's quite easy. The next one is triangle. When you know the base and the height, this is the base, this is the height. It's just A equals 1/2 BH. When you don't know the base and the height, but you do know two sides and an angle, you have to use a bit of trigonometry. But it's just really plugging in and say that's we'll refer to this as angle C, and this is A. So we'll refer to it as angle theta, and this is A, and this is B. This is a triangle. Area equals 1/2 AB sine theta. Now, we won't really be using this one much, but it's only a bit of trigonometry, and it's nothing major. And we also need to know the kite formula. You need to remember these formulas. You don't get them in the exam. It's not like AS when they give you a formula sheet. So this length here is called A. And this length here is called A. And this length here is called B. And the formula for this is 1/2 AB. And it's also 1/2 the product of diagonals, but I don't use that one very much at all. But it actually is the product of diagonals, because this is like here, and that's there, and that's there, and that's there, so this is also B. And finally, trapezium. No, that's more like a rhombus. Trapezium, two parallel sides. This is called A, and we know this is called B, and this length here, I might actually do that in a different color, because I might be getting a bit hard for you guys to see. This here is called the height. So the formula A equals 1/2 base. Ooh, no, that's the triangle formula. 1/2 A plus B, A plus B, H. Okay. And so those are the basic formulae. So, let's try a question. Yeah, let's try a question. This is question number 9. Okay. This is a rough sketch doing here. And this is like this, like this. This is 3C, and this is 6C. Ooh! It's actually meant to be in meters, but the units don't really matter. You can still use your mark. And this is filled in. This is also filled in. These are filled in. And we also know that this is 5M, and we also know that this area here is 7M. Because this apparently is not quite regular. Okay? This is on page 93 of your book, if you're wondering. So, the first thing we need to do is we need to find the area shaded. So basically what I can see is I can see a trapezium here, and I can also see a rectangle. I can see that the area shaded is going to be the area of the rectangle minus the area of the trapezium. Now I'm going to clear this, if you have the book, you should still be looking at the diagram. And so first we're going to find the area of the rectangle. We know the formula for the rectangle, A equals BH. And we know, and we're going to do this in slightly different colours. For the trapezium, it's 1/2 AB, A plus BH. Okay? Let's see. So first we need to find the area. Now we know that the area, total area, is going to be, A is going to be equal to 5 times 3 plus 6. So 5 times 9, which is then equal to 45. Okay. And then for our rectangle, we just plug it into a formula. Oops, that's the wrong color. Didn't change the color. If I don't change the color, it's not good. See color. Right. So now I've got A equals 1/2. Now we need to find A, which is 3. 3 plus 7. And H we know is 5. Okay, now I'll just get my calculator here. Here it is. And I'm going to solve this. Okay. 1 fraction 2 times 3, bracket open, 3 plus 7, bracket closed, times 5. Okay, it comes up to 25. Now what we need to do is we just need to get these. Equals 25. And what we do is we chuck the negative sign between them, subtract, which is then equal to just 20. That's our answer. So the answer to that question is 20. And most of these questions can be done without too much thought. They are all pretty easy, really. Yeah. The main problem here is just remembering the formulas, because once you know the formulas, you can do all of the stuff without much hassle at all. You don't really need to worry about it too much. Let's just see. Yeah, it's correct, definitely. Just double checking. So, we should. I'm just gonna go over the A equals 1/2 sine, AB sine C formula with you. Now the sign is a function that's on your calculator, if you've got a decent scientific calculator, and it's basically a trigonometrical function. Now I'll explain this in more detail when we're actually doing trigonometry. Okay? So let's have a look at what we're doing here. Now I'm doing this in a, you might know, so we're going to use this one. Now, to go anything with geometry when I'm drawing shapes, I'm actually going to use the thicker pen because I think it's easier to see. But when we're doing stuff with lots of numbers, like when we're doing matrices stuff, we'll go back to using this. But yeah. So, thick pen for geometry, mensuration, trigonometry. Trigonometry. We'll also be using that for graphs, sets, and matrices, but not for transformations. So, basically, we've got a triangle here. This formula is really just not much harder, but it just looks a bit daunting because it's got that sign in it. Okay, so let's draw a triangle. Okay, and we've got an angle. We know this angle is 40 degrees. And we know that this is 5, and this angle here is 6. So let's calculate. So we know that A is equal to 1/2. I still think we should stick to the thick pen for this. A equals 1/2 times AB, which is just 5. Okay, 1/2 and 5, 6 times times sine C. So we do this like this. We SIN and sine of 40. Okay. Make sure your calculator is in degrees mode. To do this, go to your calculator. Have a look in, I'm on a Casio EFX 82AU Plus. If you don't have this calculator and you don't know how to do it, just ask me and I'll be able to give you some information, or Google around. So what you do, I'm pressing shift mode setup. I'm pressing button 3, so it changes it to degree mode. Degree is the only mode you'll use in IGCSE. You will use radians later in AS mathematics if you decide to move on to that, and you won't really use grads. Although they were invented for the metric system, but they never really caught on. So let's just type this into our calculator. 1 fraction 2, bracket open 5, bracket close, bracket open 6, bracket close, times button, bracket open sine. Let's call it sine button. It's S-I-N, but it's pronounced sine. S-I-N, and then you put the sine, press the 4 button, 0 button, close bracket, and that comes out to equals 9.64. Good. And there are also some more questions using this. Now, we also need to know about circles. For the area of a circle, this is for the DRG. This is when you're using degrees. You get 1/2. Whoa, what's that 1/2 there? It's just pi r squared. You also need to know for the angle. So that's for the circle like this, where this is r. Pi r squared. What you also need to do is you also need to find out the segment. You know, like a sector, like this. It's sort of like a slice of pie. You got to figure out the area of this. And there are two ways of doing this. Now, there's one which is the normal way of doing, which uses degrees. And it's like this: A equals n over 360, and it's quite an ugly formula, times pi r squared, where n is the angle. Or n, other people you might also know here as theta. You can also do it like this. Yeah. And this is a method you'll use a lot more later in maths. Actually involves radians. And I'll just get it. My other book. Radian section. That's radians. Okay, here it says formula for when you're doing the area of a sector of the circle. It's just this: A equals 1/2 r squared pi. Now you can only do this when your angle is in radians. Now I'm a bit going slightly over the level required for IGCSE maths, but I find this method is quite a bit quicker. Okay, so this must be in radians. Has to be in RAD. You don't need to put your calculator in radians mode to do this. So I'll just put this up here again. A equals 1/2 r squared theta. You just need to know how to convert. If you're going to use this method, you need to know how to convert from radians to degrees. Let's get this up here. Yeah. Where is it? Identities, graphs. Okay. Here it is. So basically, we know in radians 360 equals 2 pi radians, because a radian this is 1 radian, where R, and R are all equal. When they're all the same. Now there are pi radians in 180. The formula to convert degrees to radians, you don't need to know how to do it the other way around. Converting to degrees to radians is done like this. You just do your degree value, which is n, times pi over 180. And that's all you have to know about radians. Although you don't have to, this procedure was totally optional, and you don't have to use this formula if you like. But this is the formula I used. I didn't use it, I didn't know about it. This is the formula I would use if I was to do it now. So back to the IGCSE stuff. You can also they also sometimes ask you to do calculations with mini circles and semicircles taken away, but it's all pretty much straightforward. Another thing you should know is that the perimeter of a circle is equal to pi d, or 2 pi r. Okay, just as a side note. Then you have arc length and secant area, and I'm running out of time. We'll just finish off on how to do a chord of a circle. A sector of a circle. So segment of a circle. Now this is a bit confusing because people say, would you like a segment of orange? They don't give you a piece that's sort of like this. I can't draw today. They don't give you a piece that is they don't give it the piece like this. They do not give you that piece. They actually give you a sector. So you can say, no, I'd like a sector of orange. Okay, putting that away. We need to know the center. Oh. Now to find this, we first need to find the area of the. We just need to find the area of to find this area, which I'll do in a red. No, that's pink. That's all in red. This is our area. So what we need to do is we just need to find the area of the sector, not the segment, area of the sector, minus the area of the triangle here. Now, we'll often be given this angle here, theta. We'll also be given, say, A and B. So I will do one example with you. Okay, so here's our angle. And then we got here. Boy, that's not what I want. Make it a bit bigger. Okay. And that's center. We know this thing is 40 degrees. We know this is 5, and this must also be 5 since it's a radii. We got to find that's really all we need to know, is it? Yeah, that's all we need to know. The first step, let's find the area of the sector. Area of the sector is given by n over 360, or if you want to do in radians, you can do that yourself, times pi r squared. We know that n is 40, so it's actually 40 over 360, times pi. We also know what r is. R is pi, 5 squared. Now this comes out to, on the calculator, 40 over 360 times pi 5 squared, which is then equal to 8.726. 8.72. 8.73. 8.73. Now in another color, we need to find out the area of the triangle. Area of the triangle is going to be equal to 1/2 AB sine C. AB sine C. This is going to be equal to A equals 1/2 5 times sine 40, which is just on the calculator, 1/2 times 5 times sine 40. And sine 40 equals 8.03. 8.03. And then we just have to do a simple subtraction here of these ones, which comes out to 8.73 minus 8.03. 8.73 minus, hey, I can actually adjust my heat by doing my calculator. 8.03 equals just 0.7. 0.7 units. Units squared. Okay, okay. So thank you for watching. It's a bit long. This show's a bit long. But so we'll see you next time we're doing volume and surface area. But if you have any questions or if you didn't understand anything, just leave a comment. But I will guess I'll see you in the next tutorial. So this is Red Tutorials signing off, and I guess I'll see you next time. See ya.